Welcome back, engineers. In this video, let's look at what is back of the envelope estimation, how it's supposed to be done, and we will have a look at an example of how to do it. I hope you're ready. Let's get started. So let's start with the question, what is back of the envelope estimation? We have already covered this a little bit in the previous video. Back of the envelope estimation is nothing but estimating a system design for its capacity even before writing a single piece of code, right? So it is nothing but an estimation, right? What it is not is exact. We are not looking for exact numbers here. Numbers don't matter here as much as long as we are able to estimate the scale of the system that we are trying to design for, right? So it is an estimation and it is not exact numbers. So what is tested in back of the envelope estimation whenever somebody is asking you for a system design estimation, either through an interview process or when we are designing a new system and you want to do capacity planning? These are some things we want to look for. So the interviewer is expecting structured thought process. So any interview, even when I'm interviewing, what I'm looking for is the structured thought process. Are you able to logically break down the problem into smaller moving parts and see how they are connected together and how the entire thing works together as a system, right? So that is what we are looking for. Another thing that we are looking for is identifying bottlenecks and trade-offs. So any system design is not straightforward. The design that I am doing for, let's say, Google Drive will be completely different or maybe overlapping with some points with your Google Drive design. The functionality may be met, but the exact design may be different from each other, right? So we are not looking for the exact design. There is no foolproof solution for any particular system design question, but we are looking for identifying bottlenecks and trade-offs. How are we able to see the options that we have for making a decision? What are the pros and cons, and how do we make a decision? What was the judgment finally taken? Everything is recorded as architecture decision, and that is what we need when we are discussing bottlenecks and trade-offs, right? And another thing that we want to see is justifying assumptions. It is okay to make some assumptions. Not every scope will be 100% clear. So you can assume that you're going to make use of, let's say, a particular authentication system because that is what is provided by the cloud provider and it is very simple to use and so on, right? It's okay to make such assumptions, but we need to be able to justify. We cannot just say that this is the solution I want to propose because that is the only one that I have been working on, right? As a system designer, we need to be familiar with the multiple options that are available and make the right choice depending on the question being asked or the problem which we are trying to solve for, right? So these are the main things that we are looking for when we are doing back of the envelope estimation. Now let's see what are the things that we need to keep in mind before approaching any back of the envelope estimation. So first thing is to have a mental toolkit. So we have already covered some numbers in the previous videos for, let's say, latency, throughput or storage, and these are the minimum things that we need to keep in mind, right? So we need to at least remember that RAM is faster than disk and disk is faster than network, right? So RAM is 100 nanoseconds, disk is 30 milliseconds and network is the slowest with about 150 milliseconds for a round trip call, right? So this is the minimum information that we need to keep in mind. And regarding throughput, this is a very important number to keep in mind. 86,400 seconds are there in a day, and we can always round it up to 1 lakh or 100,000. So always try to round up the numbers to a nearest 10 to the power or 2 to the power so that it will be easier for calculation. And like we discussed, we are not looking for exact number of bytes that we need, but we are looking for the overall estimation or an approximate estimation for the size of the design. And the next thing to remember is storage numbers with the power of 2 and 10. We have already discussed this in very detailed manner in the previous video, so definitely check it out if you haven't done already. So we need to remember the sequence kilobyte, megabyte, gigabyte, terabyte, petabyte, exabyte. And I've already discussed a phrase to remember this easily in the previous video. And we also need to remember basic data types and sizes, right? Also remember how to convert power of 2 to power of 10, which we have covered in the previous video when it talked about storage. So these are the minimum things that we need to keep in mind before going to any interview or doing any system design. Now let's see the framework for implementing this. So the back of the envelope framework has 4 steps. First step is to scope the problem. So any design problem will have 2 parts. One is the functional requirements and another one is the non-functional requirements. So you will solve the functional requirement part depending on the problem. For example, if you're designing for YouTube, you will be looking at video processing, video uploading, downloading, streaming and things like that. These are the functional challenges for designing YouTube, right? And when it comes to non-functional requirements, how do we scale it up for many number of users? How do we handle latency, how do we handle so much throughput, how do we handle storage of all these videos so that we can achieve larger scale, is something we are looking for. So when we are doing back of the envelope estimation, we are mainly looking at the non-functional side of things and not the functional side of things. Functionality will be achieved through identifying different services, breaking down the system into different services and components, and see how they are working together to function the system, right? So here we are looking at scoping the problem in terms of non-functional side. So we are trying to ask different questions. We will not assume anything. We will try to ask different questions to any stakeholder or interviewer, and we are asking things like this: how many are the daily active users that you're estimating, how many are monthly active users, and what will be the growth of these users, and so on. And this is another important question to ask: what will be the ratio of reads to writes? How often is the system writing to the database, and how often are users reading from the database? So this ratio will actually impact the design of the storage side of the system, and maybe it will impact your caching layer and also data retrieval services, right? Another important question to ask may be: how long do we need to store the data? So this will be useful when we are trying to design archival processes, backups, and things like that. So the questions can be endless here, depending on the scope of the problem you can ask, but try to ask in terms of the usage of the system, right? And the second step would be to estimate the traffic. We already know what is traffic by now. It is mainly talking about throughput of the system. So what do we do when we want to estimate traffic of a system? We are looking at total reads and writes per day, right? How many people will actually be writing to the database? For example, if you're doing Instagram, how many average number of uploads you're expecting per day, right? So when we know something per day, we already know how many seconds are there in the day, which is 86,400, which will be rounded up to 100,000, right? So we can calculate by dividing the day into dividing the day by number of seconds, and then we get the average QPS. QPS is nothing but queries per second, either on the write side or on the read side, right? Then we can get the peak load of the system by doing 2x or 4x for the average QPS, right? So definitely give it a mention when we are talking about throughput of a system. Next, we will go for estimating the storage of the system. So how do we get the storage? Calculate size of the single data unit. There will always be a main data point for any design problem. If it's YouTube, it will be the video. If it's Instagram, it will be the photo. And if it's a tiny URL problem, it will be the URL, and so on, right? So what is the minimum data size that is required to hold this particular unit is what we are looking for. So it can be one tweet, one photo, or one URL. So how do we get the size of this single data unit? We will make use of the common data types and sizes that we have looked at in the storage video, and we will try to design a small table around it. We'll have an ID column, we will have, let's say, the URL that is holding something, we'll have a timestamp, and so on. So for each row, what is the size of the record that will be required per record, right? That will be the size of the whole record, and we will multiply it by the number of writes per day. That is how we get the size required per day, and then we can project into months or years, whatever we want to, once we have writes per day, right? So this is how we get the entire storage of the system. And finally, the fourth step will be to apply real world multipliers. So just storing something will not be enough. In the real world, we will need to do backups, we will need to do indexing, we will need to do replication, and many other things, right? So always account for these and do a 5x to 10x for the real world multipliers, and that will give you the whole scope of the storage requirement for the entire system, right? So that is a framework. Now let's try to implement this framework using an example. So for this, we're going to use a URL shortener service. So if you don't know what is URL shortener, it is these applications like Tiny URL or Bitly and so on, right? So we have a long URL, this string will be converted into smaller URL, and this smaller URL, when we hit it, it will redirect to the main URL, right? So this was designed mainly during the Twitter early days when character limit was an issue, and it is a very fantastic tool when we want to limit the number of characters, right? So what will be the scope of it? Like I said, we are not looking at the functional scope. We are not going to discuss how to convert the longer URL into smaller URL. That is the functional side of things. But what we are really looking for is the scale of this system, right? So we are asking questions like, so how many new URLs are we expecting per month for this system? So let's say we got the input as 500 million, right? 500 into 10 to the power of 6, right? And what will be the read to write ratio? Let's say we got this number as 100:1, right? So for every URL that is being written, there will be 100 reads for that system. So this is a read heavy system. So this is the scope of our system. Now we will go on to next step, which is calculating the throughput. So like I said, once we have the number of reads or writes required per day, we can calculate the throughput. In this case, we are given that 500 million per month. So we will divide it by 30 to get it per day, and then we will divide it further with 100k to get the number of writes per second. So in this case, we will get around 160 writes per second. And because we are looking at 100:1 read to write ratio, we will just multiply this number with the number of reads. We will get 16,000 reads per second. So this will be our throughput requirement. And what will be the peak QPS? I did into 2 here to get the peak QPS. So this will be around 32,000 reads per second. So this is how we can get the number of maximum reads per second that we can expect in this system, right? Now let's move on to storage. So for storage, this is how we can calculate it. So in the case of tiny URL problem, we are looking at designing one small table, something like this. We are going to have an ID column. We are going to have the user ID who is actually creating this record. We are going to have a short URL. We are going to have a long URL, which will be the actual input. And we're going to have a timestamp column as well, right? Let's say this is my table, the minimum requirement for designing a tiny URL system, right? So what will be the data types for this? So ID and user ID, I'm going to use big int because we are expecting around 500 million per month, which means that ID column will keep growing, and it is not going to be enough to just use int because it is going to exhaust really soon. We're going to use big int for this, and the same will be used for user ID as well. So we can go for 8 bytes and 8 bytes for this. And for short URL, we are looking at 8 character string. So we are looking at simple alphanumeric characters here. So which we can go with ASCII characters. And the size requirement for this is 8 for the 8 character string. And for the long URL, made an assumption that we are going to have on an average about 100 characters in the long URL. And URLs also are generally alphanumeric in nature. So we're going to have a 100 character string, and we'll require 100 bytes for this. And timestamp will have 8 bytes. So the total of 132 bytes are required for this particular record. So if you also want to estimate the number of possible combinations for the short URL, you can go in this fashion. So the tiny URL will look something like this: bit.ly/ some tiny URL. Let's say we are giving out a maximum of 8 characters, right? So how many such URLs can be possible? If you are only supporting lowercase characters, we can have 26 to the power of 8. If it's lowercase plus uppercase, we can go up to 52 to the power of 8. If it's alphanumeric, we can add 10 more. We'll get 62 to the power of 8 combinations, right? And now let's do the final storage calculation. So we know that per URL, we need 132 bytes. That is one record into the table. And per month, we are expecting 500 into 10 to the power of 6, which is 500 million. So 132 into 500 into 10 to the power of 6, which will give us about 66 GB of data, right? And if we want to project it for 5 years, we're going to do that for 60 months, and this will come to be around 4 terabytes of data. So this will be the overall projection for the data requirement or storage requirement for a URL shortener service. And let's do a final step. We will apply the real world multipliers. We are just going to do 5x of this, and we will see that we are going to need 20 terabytes of data for designing this whole system or maintaining this whole system for, let's say, for the next 5 years, right? So that's how we can do back of the envelope estimation, guys. This was a simple example. The questions can get quite complex depending on the situation and the kind of answers you're developing during the interview or when you're doing system design in general, right? So I hope you got some insight from this video about how to do estimation. I hope you will get comfortable with doing this as you practice along for different types of questions. If you have any doubts, definitely let me know in the comments below. I would be happy to help you. Thank you so much for watching, guys. I will see you in the next one. Please leave a like if you found this helpful. Please subscribe if you haven't done already so that you don't miss out on any future videos. Thank you so much for watching. I will see you in the next one. Cheers.